The spine, the backbone. If you do not have it figuratively, you're a coward. If you do not have it literally, well, you're in really bad shape. The spine is the all-important connection of our head to our body and our limbs. It contains and protects the spinal cord, which is the main conduit information from body to brain and brain to body. It sees forces that exceed our body weight by 10 times. Spine health is very important for our ability to move and interact with the world. 2 current and former UFC champions have recently had to deal with this stuff just in the past year. Unfortunately, back pain is one of the top reasons that people see a doctor. The back is susceptible to injury and breaking down with time. When the spine breaks down or breaks, bad things happen. I quickly realized that even a simpler introduction to the spine was going to be long. So I broke it into 2 more easily digestible videos. In the first video, we will talk about the basics of spine anatomy and really focus on what should be happening in our spine for it to work right. I also talk about what popping or cracking of our joints may be. In the second video, I talk about some of the ways that our spine can break down and how we can help prevent these injuries. I'm Dr. Lucius Pomerantz, board-certified orthopedic surgeon, black belt in Brazilian Jiu-Jitsu, trying to challenge my mind and body every day, here to be a free source of information on how our bodies move and how to reduce confusion and anxiety about our injuries in the context of combat sports. By laying a foundation of understanding about the spine in these videos, future videos will talk about specific injuries to the spine and their treatments, as well as specific attacks, like the twister, that stress the spine and back. So here we go. The anatomy of the spine. The spine is a column of 33 to 34 bones called vertebrae stacked on one another. There are 7 cervical vertebrae, 12 thoracic, 5 lumbar, 5 sacral, and 4 to 5 coccygeal. I'll break these down further in a moment. Today's video will focus on the cervical, thoracic, and lumbar regions, so you only have 24 vertebrae to think about. This structure of how these bones are stacked is crucial to the supporting of the head and trunk in posture, linking the upper body and lower body, and protects the important structures of the vertebral arteries and spinal cord. The cervical spine is the neck. The big bone you feel at the base of your neck is the lowest cervical vertebrae, the 7th cervical vertebrae. The cervical spine has the most range of motion. It flexes and extends, tilts and turns to a large degree. It also encases the vertebral arteries that eventually feed the brain. The thoracic spine is the mid-back. It has a little rotational ability, but compared to the other bigger 3 parts of the spine, it doesn't move much. This is partially due to the rib cage confining it. But if you think about it, the thoracic spine and ribs are protecting a lot of important things. The heart, the lungs. So, you want it to be fairly rigid. Otherwise, those important things would get mushed around when you're moving or getting moved. The lumbar spine is what we think of as the lower back. Its vertebrae are the largest of the vertebrae as they see the most weight when we, as bipedal animals, we walk upright, are upright. The lumbar spine has flexion and extension and a little rotation. This flexion and extension influences the pressure within our abdomen, and the pressure in our abdomen can influence the forces that our spine sees. As a landmark, the top of the iliac crest, the bone you feel at the side of your pelvis, is at the level of the 4th lumbar vertebrae. This is a good landmark when doctors are going to do a lumbar puncture, as the actual spinal cord has ended by that point. I'm just going to breeze past the sacrum and coccyx in this video. They are within the pelvis. They don't move. They can be involved in injury. Ever break your tailbone? That is a coccygeal fracture. But for the sake of brevity, we will not talk about them too much here. The spine has a very distinct set of curves. These curves are cervical lordosis, thoracic kyphosis, and lumbar lordosis again. When these curves don't fall within normal boundaries, there can be issues. And sometimes when they start going off to the sides, it can be called scoliosis. Now, when we're born, our whole spine is kyphotic, meaning concave towards the front. But as we start to hold our heads up as babies, we get cervical lordosis. And then as we start to walk, we develop lumbar lordosis. This curvature and reverse curvature is a very important adaptation that allows us to walk upright and limit the energy required to do so. The muscles of the abdomen and back are very important in stabilization of the spine as well. Keep this in mind when we're talking about injuries and injury prevention in the next video. Also, note that as things pull on the pelvis or the head, surrounding musculature and spine must compensate. For the pelvis, it's the lumbar spine, and for the head, it's the cervical spine. Again, I have to stress the importance of muscle stabilization and balance for spine health. And this is not only the muscles around the spine, as we can allude with the pelvis and the hamstrings and the quad muscles and all that. So, as you may know, the spinal cord exits the brain and enters the spine. It then starts shooting out nerves between the vertebrae and then connect to the rest of our bodies. Some of these nerves go all the way to the tips of our fingers or toes. There are 31 paired nerves, one for the left, one for the right, that exit the spine, pretty much one at each level. The actual spinal cord then usually has tapered off to just branches by the time it reaches the second lumbar vertebral level. As a refresher from other videos, nerves are the electrical system of our bodies and send information from our brains to our bodies and back to the brain. If the spinal cord is severed at a certain level, the ability to feel and move everything below that level is compromised. The nerves to the arms mostly come from cervical levels, and the nerves to the legs mainly come from the lumbar levels. Of course, the nerves that go to our legs have to pass through our neck. In between the vertebrae are vertebral discs. These discs are also some pretty amazing engineering based on what they are expected to do for us. They must be a shock absorber as well as be able to resist twisting and flexing and extending. And theoretically, they have to do it every single moment we are upright for our entire lives. To be able to do both shock absorption and resistance to stretching, they have two components: an outer firm layer called the annulus fibrosus that helps resist tension and twisting. Inside of this is the nucleus pulposus, which is a cushiony, high water content substance that is the shock absorber. The situation that results in the highest pressure on our lumbar or thoracic vertebral discs are when we are sitting or crouched, flexed forward with weights in our hands. The farther from our body that we hold those weights, the higher the disc pressure. Remember this when it comes to the injury stuff. As the day goes and we are upright, some of the water does get pushed out of the discs, and we do shrink a little. Then, overnight, while sleeping, and with less force on the discs, the water gets back in and height is restored. As we age, this process does not work out as well. Our discs lose height and we get shorter. The last important structure that you should understand are the joints that connect each of these vertebrae. There are several articulations or joints where vertebrae must move past each other. Obviously, the movement of vertebrae must be very controlled and specific, or some bad things can start happening. So popping, back, popping, cracking. What is it? Well, there are a lot of theories on this. The most prevalent and most supported in research on fingers is that of cavitation. By pulling a joint apart, tension is created, resulting in a vacuum. The vacuum creates enough force to suck the dissolved gases that are located in the joint fluid into a bubble and pop. It then takes time for the gases to return to their normal state, which is why there is a period of time where you cannot pop the same joint. This does not explain all joint popping. Perhaps it explains some of the pops you get when your neck is cranked, such as jiu-jitsu or a chiropractor, but it does not explain it all. It could be ligaments being stretched, or small loose bodies inside joints rolling around, or tissues not having a smooth surface to glide past. Could be lots of things. As alluded to, the spine can see a lot of force. The spine routinely sees forces of 2 times more than our body weight with even simple activities. When lifting something heavy, those forces can be 10 times our body weight. Our spine keeps us upright and balanced. It protects some very important structures. Hopefully, it is clear that we should all be doing our best to take care of our back. In my next video, we will talk about what happens when things break down and how to prevent it. Again, I'm Dr. Lucius Pomerantz. Like, share, and subscribe. Be good to your body, and it will be good to you. Get after. Let's keep moving.